Hello, this is Mrs. Arnold. Today we are going to talk about scientific theories and laws. The question you should be able to answer at the end of this video is, what are the differences between scientific theories and laws? If you recall, I talked about this in the first video, What is Science? Highly recommend that you re-watch that video, but I will go over the basic points before I go into further depth about theories and laws. A theory does not become a law. A theory is not a hypothesis. So there should not be in science class any, you shouldn't say that, oh, it's just a theory, because a theory is something much more than just a guess or something that we could either take or leave. A theory is not a guess. A theory is based on many experiments and therefore many observations and data, facts. Theories and laws serve different purposes. Theories are broad and laws are narrow. So a theory is broader than a law. That means it covers more things. A law is narrower and focuses on specific conditions. A theory's job is to explain why phenomena occur. Meanwhile, a law describes what phenomenon happened. Laws are often written as equations. Even with additional evidence, theories do not become laws. Theories explain laws. However, not all scientific laws have accompany scientific theories. Okay. A scientific theory is an explanation based on many observations during repeated investigations. So, many observations in repeated investigations. So that means that there have been countless experiments that have backed up or helped construct the theory. Theories are going to be valid only if they meet the following criteria. So they have to be consistent with observations and supported by experimental or factual evidence. So this is one reason of many that why flat earth theory is not a theory at all. It isn't science. First, if you look at this, it's not a theory because it's not even valid as a scientific theory. It's not consistent with observations, and it's also not supported by any factual evidence. Theories also makes predictions that can be tested. So the theory has to be testable. We have to be able to run an experiment about it. And also it has to be the simplest explanation. Of the observations. A theory can be changed or modified with the discovery of new data. Remember, science is tentative. And theories also answer why. One early theory of continents moving was continental drift. This was proposed because of fossil evidence, among other things, like how the continents look like they fit together like a jigsaw puzzle. It was actually proposed by a man named Alfred Wegener, and he was German, so the W is pronounced like a V. He actually was the one that proposed this theory. And as you can see, we have several fossil evidence of land animals that lived across several continents that are no longer connected and that couldn't possibly have swam across the ocean because they are land animals. In particular, we can look here and see how this creature lived in both South America and Africa. And also there were other landforms besides just the shape of the continents that Alfred Wegener based his theory on. But no one accepted his theory of continental drift because there was no explanation about how the continents move. He didn't have a mechanism to describe the movement of the continents. So he actually died thinking that, no one was ever going to accept his theory. His theory, continental drift, was replaced with the theory of plate tectonics. You could say that actually the theory of continental drift was modified because we discovered the mechanism of how the continents move. The continents are on top of slabs of rocks called tectonic plates, which are constantly moving. We can see evidence of this movement everywhere, but in particular, we can see evidence of it in Iceland. That is where we have sea floor spreading that is happening at the Mid-Atlantic Ridge and is pushing the North American plate and the Eurasian plate apart. So the Mid-Atlantic Ridge runs the length of the Atlantic Ocean. But in Ireland, you can see where this is happening with your own eyes. It's happening everywhere, even in the very deep ocean. But it's much easier for just us common folks to go to Iceland. I probably said Ireland earlier. It's much easier for us common folks to just go to Iceland, and you can actually go to Iceland like these people have done, and on one side there would be the North American plate, and on the other side would be the Eurasian plate. And we can actually measure how fast they are pulling away from one another. You can also see evidence of this in Africa at the African Rift Valley. Volcanic activity is also further evidence that the plates are moving. Once again, this theory improved upon continental drift. The fossil and rock evidence of continental drift is still a component of plate tectonics. A scientific law is a principle that describes the behavior of a natural phenomenon. It is a rule of nature the event described by a law is are observed to happen the same way every time. So event So events described by a law are observed to be the same every time. Another way to say that is that laws are universal relationships related to the way that some aspect of the natural world behaves under certain conditions. Laws describe what happened, and they are often equations. So that is a good indicator of whether the thing you're looking at is a law or a theory. We're going to look at two laws today. The first we're going to look at is Newton's first law of motion. Newton's first law of motion states that an object at rest stays at rest, or an object moves in a straight line at constant velocity unless acted on by an outside force. So, this law is going to explain why planets orbit around the sun. So imagine that you are in the center here, right here of the circle, and you are swinging the ball on a string in a circle around you. Okay? When the string is released, the ball will fly straight away. It will not fly along the curve. All right? So, because our planets are going and moving in a elliptical motion around the sun, we know that the sun is the force that is acting upon it. Because remember, an object is either going to move in a straight line at constant velocity unless it's acted upon by an outside force. So that is how Newton's first law of motion explains why planets orbit around the sun. Boyle's law is another example of a law. It describes the relationship between pressure and volume of a gas at constant temperature. This picture shows that the temperature in this system remains the same, constant, which is 300. And in this experiment, we have a gas. And at first, we have the pressure of the gas at 1, and we have the volume of the gas at 4. But you can see that as we compress the knob, the volume of the gas is going to decrease to 2. We press the knob and we decrease the volume of the gas to 2. And the pressure, as that happens, rises from 1 to 2. So that is the relationship of pressure in volume. If you decrease the one, you will increase the other. That happens if you're at constant temperature. So what did we learn today? We learned the differences between a law and a theory. A theory is an explanation that answers why. A law describes what happens, and a theory does not become a law. I hope you have a better understanding of theories and laws after watching this video. Have a great day.